Well, for problem number 1, what we have is we have the square root of x minus 2, and this is having a shift. Remember, the shift with the negative 2 means that it's going to shift to the right. And here's the graph that we should have for the answer for problem number 1. For problem number 2, we change this into x plus 4 quantity squared. And this is going to shift the problem, but instead of shifting it to the right like the last one did, it shifts it to the left. And so we've moved the graph 4 places to the left. And then lastly, problem number 3, what we have is the absolute value. And so we have the absolute value of x minus 3 plus 2. And now this is going to do 2 shifts to it. One is the shift up with the plus 2, and the absolute value with the x minus 3 is going to shift this to the right 3 places. So it's shifted to the right 3 places and up 2, and this is the graph that we have. Go ahead. Well, problem number 4, what we have is the systems of equations with 3 variables and 3 unknowns. What we need to do is select one of the variables to eliminate. The easiest variable to eliminate in this case probably would be the y. And so I'm going to take the first 2 equations and eliminate the y variable out of those. So what we have is x plus y minus z is equal to negative 1 minus 4x minus y plus 2z is equal to negative 7. Adding these 2 equations together, what we're going to end up with is minus 3x plus z is equal to negative 8. The y variable has been eliminated. Now what I'll do is take another equation that needs to include this third equation, and I'll take it with the first equation here, the first and third ones, multiplying this first one by 2. That way, when I add them together, the y variable will eliminate. So we'll have 2x plus 2y minus 2z is equal to negative 2. Taking this equation, we'll have 2x minus 2y minus 5z is equal to 7. Adding these 2 equations together eliminates the y and results in 4x minus 7z is equal to 5. So now what we have is eliminated one of the variables, and we have 2 equations, 2 unknowns. Now what we'll need to do is take these 2 equations and eliminate a variable out of these. The easiest variable to eliminate is the z. Notice we have a z in both cases. Let's multiply this one by 7, so when we add, it'll eliminate this one. So we'll have negative 21x plus 7z is equal to negative 56. Multiplying this one by 7. Write that here. And then taking this equation, we'll have 4x minus 7z is equal to 5. The z is eliminated. We have 17. Negative 17x is equal to negative 51. So x, in this case, is equal to 3. So we found out what x is equal to. We'll now go back into the equations and find out what the z value is. So we'll take this equation and solve for z. So we'll have minus 3x plus z is equal to negative 8. Plug in x is equal to 3. We end up with negative 9 plus z is equal to negative 8, or z is equal to 1. So now we have 2 of the variables found. We have the x value, the z value. We now need to find the y value. So we'll come back to this equation right here and plug in for the y. So what we have is 3 plus y minus z. So we're going to end up with a minus 1 is equal to negative 1. So y plus 2 is equal to negative 1, or y is equal to negative 3. So our solution with y of negative 3, x of 3, and z of 1 is going to be 3, negative 3, 1. This is our ordered triple for this answer. Okay. With problem number 5, again, what we're going to do is find one of the variables and eliminate it. And what variable we probably should take a look at would probably be this y and the negative 2y here. Just multiplying this equation by 2 will give us 6x plus 2y minus 4z is equal to 4. Taking this equation and putting it underneath, we'll have minus 6x minus 2y plus 4z is equal to negative 2. And when you add this together, you'll see on this side, all the variables cancel out. And when we add on this side, we end up with 0 is equal to 2. Well, this makes no sense. 0 is never equal to 2. And so what we can say here is that this has no solution.